Okay, so I will be talking about how I achieved infrastructure as code in this video. First, starting off with IP address management system, I'm using a network to codes product called Notabot, which is also a network source of truth. And I installed it, as mentioned in this document that I submitted. I've mentioned how I installed Notabot and what all things I've configured. But this is the dashboard for Notabot. Um, I had to configure locations, and for now, since there's no physical location, I have container lab as my location, um, and the location type is lab. I added a couple of devices in this Notabot, which is R1, R2, all the routers, and updated the manufacturer and the location as container lab and Arista CEOS. This is basically my network source of truth where all the devices information is stored here. As you can see, the location is lab and the device type is Arista CEOS. The status is active and I can have what platform, the manufacturer, etc. here. I also configured interfaces here. And as you can see, I added all the interfaces that are active on R1, like Ethernet 1 to VLAN 10, 20, 30, 50, 100. And just to confirm, that's what we have here. Ethernet 1 to VLAN 10, 20, 30, 50, 100. And the device is R1, the status is active, and Ethernet 1, 2 don't have any IP addresses because those are L2 links, but the SVIs 10, 20, 50, 100 have IP addresses assigned. And to show you other devices, it's the same here, 10, 20, 50, 100 have an IP address. I'm going to show one of the core routers. As you can see, Ethernet 1, Ethernet 3, 50, and 100 have IP addresses. And this is the edge router with all the interfaces with IP addresses. To assign the IP addresses, I just had to go here, assign prefixes. As you can see, there are a bunch of prefixes. It's 1100/24, 1200/24, and so on and so forth. And this is the utilization percentage of all the prefixes. Like for example, 1100/24, there are only 2 used IP addresses, and there are about 254. Similarly, if you can see here, this is a /29. You can have 6 IP addresses, and 4 of them are used. And yep, that's prefixes. And if you see IP addresses, all the IP addresses, if you see here, are assigned to the interfaces. So this is my my IPAM solution. The next one is updating passwords regularly. So, okay, so I have a script called updatepassword.py. And what this script essentially does is it logs into every router with a username and password and then updates the password randomly using this Python module called secrets. So I'm saying the length should be 5 because 0 is also counted. So it's a 5-character randomly generated password and it runs this command on every router. So it's just updating the admin password with the generated password here. And the way it is logging into the devices is using the CSV. As you can see, I have the CSV with the routers, device type, IP, username, and password. And R1 has this IP address with this username and this password. So every device has a different password. I have a systemd service for this. It's called update password, which is running in the background. And if you see here, it's waiting 1 hour before the next update. So every hour, it just updates the password. But to show that this works, I will change this timer to 5 seconds and restart the service. As you can see here, R1 password is LVCSMQ, and now it changed to AOE To show that this actually works, I have another script called PSSH. It's a bash script. And what it does is it essentially reads from the sshInfo.csv file that I just showed you, and it logs in with admin username and the password that it picks up from this. So I don't have to constantly copy this password and paste it. So I can just do PSSH R1 and it logs in using this password. So that's how I am constantly updating passwords. Now, talking about the DevOps pipeline, I'm using Jenkins as my DevOps pipeline. This is how the dashboard of Jenkins looks like. I have a job name called lab5.ise, and I just cleared all the build history so there are no builds so that I can show you how things work. For now, I'll just manually trigger a build now to show that Jenkins works, but eventually I will show you how my script automatically triggers the Jenkins job. But for now, I'll just manually trigger it. Okay, so the build is scheduled, and if you see the output says finished success, I will quickly talk about what all checks I'm doing here. So I have a Jenkins file here in the root repository of my GitHub. Basically, wherever the .git is initialized is where I have my Jenkins file, so that whenever there is a push trigger to GitHub, it would trigger a Jenkins job. So this is my Jenkins pipeline, and the first thing that it does is to check out SEM, that is from the GitHub repository. It just pulls the latest configuration. Next, in the previous assignment, as I talked about how my Jinja 2 templates are getting used to generate a YAML file to generate a configuration, the running configuration, uh, I am using something called as J2lint, which is a linter for Jinja 2 templates. If there are any syntax errors or any errors found in Jinja 2 template, it flags that. So the first thing that it does is that it installs J2lint if it's not already installed. And the next thing that it does is it's uh, checking for any errors in the Jinja 2 files. So this is my directory structure, which I will show you. Okay, as you can see here, this is just my container labs directory structure, so we can ignore this part. But this is the part that I wanted to show you. If you see, there's something called as template generator, configs, generated configs and templates. And if I go to templates, you will see all the Jinja 2 files here. Like I have access.j2 as I showed in the previous assignment. And this is basically used for generating running config from the YAML file. Right, so going back to the Jenkins file, it's just checking, it's just like pylint, where it is checking for any syntax error in a Python code. It's just checking for any syntax errors in a Jinja 2 template. And this is the templates directory wherever it's pulling the Jinja 2 files from. And if the syntax works perfectly fine and J2 reports success, then it just echoes linting successful, no Jinja 2 syntax error found. Or if it's failure, it just says syntax errors were detected, and then it'll tell the errors that were found. So as you can see here, it first pulled the latest configuration from my GitHub repository. And the next stage that it goes to is install J2lint. Since I already have J2lint, it just says requirement already satisfied. The next stage is lint Jinja 2 templates. And it is, as you can see here, J2lint template generator templates access.j2, bgp.j2, and all the other Jinja 2 templates that I have. It's just running a J2lint on that. And it passed. So it's saying linting successful, no Jinja 2 syntax were found. And it just was successful. To show you that it also fails, I will, let's say I'll go to h.j2 and I'll just put a tab here. So there it should ideally say, hey, there were issues found here. Okay, so this time I'm going to trigger using GitHub. So I will push, I'll push this change to my GitHub repository, and ideally it should trigger a Jenkins job. And as you can see here, it is building a new job here. And if you see here, this has failed. It says syntax errors were found. And if you see here, it says tabulation, but 4 spaces. Indentation should not use tab, but it should use 4 spaces. So let me fix that quickly. And I'm removing the tab here. Git push. And now it should automatically trigger another Jenkins job, as you can see here. And if you see now, there were no syntax error found. So GitHub and Jenkins are now working fine. Now I'll talk about how I've established infrastructure as code. Okay, so from the previous assignment, as I showed you, I had this one particular form here that fills out that we can fill out for generating the YAML file, in, which can be used to generate a running config file from the Jinja 2 template. So I will just fill out random information here to just show you that this works. Oh, sorry, this was supposed to be test. Say 10001, and I'm just gonna leave everything else blank for time's sake. And once I click on submit, this will save in generated configs directory r1access.yaml. Actually, let me just restart it. I will remove all the already existing YAML files and I'll just submit it again. Okay, as you can see, I'll also purge the build history and reset the build number to 1 so that everything is fresh. Okay, so now I am adding a new device, R1, with the router type as access. And now I'm not going to fill any of this information just for time's sake, and I'm just going to click on submit. Now, once I click on submit, it creates an r1access.yaml file. And since I haven't populated anything, it just says null everywhere. Now, what happens after this is this gets pushed to GitHub automatically. I will show you how that looks. I go to template generator, generated configs, and as you can see, r1access.yaml is pushed to GitHub. Now, since this got pushed to GitHub, a new build is formed in this particular job name. And if you see, it says linting is successful, no Jinja2 syntax error were found. Now, since since Jenkins reports success, on the front end, as you can see, it says the Jenkins job completed successfully. You can now proceed to push the configuration. So now this push config button is activated. But initially, if you see, this push config button was disabled. This will only and only get activated only if the configuration or Jenkins reports success. Let me try and test another thing to show you a failure scenario. So I'm gonna put a tab again here so that now ideally this should fail. What I'm gonna do is I'm gonna add R3 and the router type is core, and I'm just gonna submit it. So once it gets submitted, as you can see here, it creates r3 core.yaml, and this should get pushed to GitHub, as you can see. And in Jenkins, it should trigger a build, which failed, as you can see. It says linting failed, Jinja2 syntax errors were found, and it's the same error that we saw, that indentation should not use tabs, but should use 4 spaces. Now, in my front end, it caught this particular error, and now it says Jenkins job failed. Please review the errors in the Jenkins console, and this push config is still deactivated. So this button only gets activated only and only if Jenkins job is successful. Okay, so that was how I implemented end-to-end connectivity with my front end and my back end. Okay, so about the health check script, I have a CLI tool called NetHealth, and I can choose any device here to check the health that was mentioned in the objectives. So let's say I click R1, and now it is just scanning for any. Yep. So as you can see here, it's checking for CPO usage. It's seeing neighbor OSPF neighbors. As you can see here, it's 200,001 status up and other states as well. BGP is inactive on R1, so it just says BGP inactive. This is the route table, and it is just checking IP connectivity to the NMAS. Now I can choose another device, as you can see here. Let's say I click on R3. Now it's just checking for R3. And if you see here, R3 has BGP neighbors, so it shows the BGP neighbor states. The CPU usage is 1.6%, and the rest is the same. Now if I just click on quit, it just exits the health check tool. And that's all I have for health check tools.